I'm going to introduce one more team and then pass it over to my co-instructor, John, to introduce the last two. The next one is RecipeMe. I need to use this app all the time because while it's very easy to find recipes online, it's very hard to find ones that are good for you and actually take into account what you need in your nutritional diet. So this team has gone above and beyond to help you become healthier by really learning about your shopping behavior, which is kind of creepy, but also really cool. And so I'm going to pass it over to the team to tell you more about their app RecipeMe.
Hi, my name is Michelle Scharfstein, and my partners are Patricia Rozario and Alice Chen. And together we built RecipeMe, a web application that suggests recipes to users based on their preferences and nutritional intake. When brainstorming ideas for our app, all three of us landed on ideas related to food. None of us have been out of college for that long, and one of the biggest pain points we noticed of being so-called adults has been cooking for ourselves and making sure that our meals are healthy and well-balanced. We found ourselves creating the same food week after week and wishing that there was an application that would suggest recipes to us that we actually liked and that kept us healthy. So we created one. RecipeMe solves this problem by telling you what types of food you should eat more of and then providing recipes with those food items. The app also learns about you as you use it so that it can ensure that it's serving up recipes that are targeted specifically to what you like to eat as well as to your nutritional needs. To start using RecipeMe, a user can upload a grocery receipt as simply as dragging and dropping an image. For this functionality, we investigated a new technology, Amazon Web Services Cloud Storage, which is called S3. Our front end was created with React, so we found a React S3 library to make the component for uploading the receipts. When an image is dropped into the component, it's automatically uploaded to S3 and stored in the cloud. We can then pull down the image and save it on our server. I'll hand it over to Patricia, who will talk about parsing the receipts.
Once the file is available, the real processing work begins. We use an optical character recognition library called Tesseract, which recognizes the text in the image and reads it into a file for us to use. We then parse this file for the ingredients. This was one of the more challenging components of our application. We use a variety of regular expressions to find the ingredients within the text, using the price as an indicator of relevant lines. We then compare these lines to the ingredients in our SQLized database by using the Levenshtein distance algorithm to find the ones that are most similar. We return the receipt parsed to the best of our knowledge and let the user confirm the items. We use this confirmation as a way for our application to continue learning with every receipt. When a user confirms an item, we store the receipt representation of the ingredient with the associated table and return it. The next time any user uploads a receipt with a particular representation or abbreviation, we can easily and accurately find the ingredient by cross-referencing the associated tables. Now I'm going to hand it off to Alice to talk to you about the user experience.
In addition to learning about receipts, our application also learns about the user preferences. Every time you upload a receipt, we keep track of the number of times you have purchased a specific item. We use this information to find you recipes with your frequent ingredients so that we can ensure you enjoy the recipes that we serve up to you. We also update the order history of the user with the new items, and we keep track of the user's most recent purchases on the front end using a Redux store. Therefore, the users can view their nutritional profile being updated in real time on their dashboard every time they upload a receipt. The dashboard displays this information using interactive graphs built using Z3 and related packages. It was challenging at first to figure out how to incorporate our graphs in such a way that they'll help guide the user through our application. When a user hovers over a food group or a nutrient, we display a tooltip that will help guide the user to click for recipes. This makes a request to the Yumly Recipe API, which provides recipes with ingredients in those specific categories, focusing on the ones that the user has purchased and enjoyed frequently in the past. Users can then favorite recipes, go to the recipes website, and add the recipes to their shopping list, which they can then view on their dashboard. They can also navigate to another tab where they can search for recipes based on what they want to eat. And this tab is auto-populated with recipes based on user preferences and nutrient intake.
In creating RecipeMe, we learned a lot from the challenges we encountered and the new technologies we explored. In the end, we created an application that makes living healthy more manageable, and we had a ton of fun doing so. We hope that you enjoyed our presentation, and go check out RecipeMe.
That was well done. As a fan of the Soylent movement, I think they're in trouble because this actually makes cooking seem actually approachable, and I like that this team solved a number of technological challenges to really make a real difference in this problem.
Yeah, I think it takes one thing I see a lot of students about student projects that they oftentimes will take paths that are like just take a lot of guts to go down, right? I think like parsing a receipt is something that is a hard technical problem, right? To put Tesseract and LSH,
easy.
yeah.
It is actually challenging. I'm sure they found out.
Yeah, and so that they were able to get anything accomplished is pretty awesome, I think. And a few interesting, clever hacks on making the matches. So very cool.